also use passive solar energy to space heat our homes. In this case, we're going to use the house itself as the solar collector and a way to store the energy. We can use a passive system with no mechanical devices or fans, no electricity. So mainly we're going to let sunlight in through south-facing windows and store that energy with the materials of the house, with the slate and concrete and water. Keep it out of the sunlight, out of the house during the summer with overhangs. And an energy conservation house such as this one, which is in New York State, only uses 25% of the energy a traditional house uses. So look at this house, right? We have a big overhang over these large windows, and that keeps out the high summer sun. But this looks actually like it's an awning that could be retracted and let in the low angle winter sun. And here we have 2 attached solar greenhouses, and we also have lots of windows here on the south facing side and very few windows on the other sides of the house, just a couple for light. This house probably has excellent insulation as well. So the essential elements of a passive solar heating system is excellent insulation, solar collection through south-facing windows, and thermal storage, a way to store some of that heat energy. Like I said, concrete and water are good ways. So within this category of heating, this passive heating, there's 3 different types of systems. There's a direct gain system, an indirect gain system, and those attached solar greenhouses that I pointed out on the picture. So direct gain is large south-facing windows letting in the sunlight, and then thermal storage material like concrete, slate, water, or brick placed in the house to absorb the solar radiation, so directly exposed to that sunlight. Things like massive masonry floors and walls that can absorb that energy during the day and radiate it back into the room at night. In this picture here, this floor is made out of slate, and it can absorb that sunlight all day long. It's right in the path of the sun. Like I said, the overhangs are very important. This is what keeps out that high angle summer sun, yet still lets in that lower angle winter sun. And like I said, you have to have a good concrete floor and excellent insulation. It's often good to have insulation that you can put over the large windows at night. This graph shows us a passive solar building in New Hampshire. It was a commercial building on 3 sunny but cold winter days. Now, this building has large double glazed south-facing windows. No insulation is put on them at night. And thermal storage consists of that dark slate floor over 4 inches of concrete slab and phase change materials in the walls. Phase change materials are materials that will change from a solid into a liquid at a temperature, like 70 degrees, something like that. So that it absorbs energy 80 degrees during the day, and then at night it can radiate that energy as it changes back into the solid form. So outdoor temperatures over these 3 days range from 20 degrees Fahrenheit down to minus 15 degrees Fahrenheit. And this house, without commercial heating system, this building stayed above 60 degrees Fahrenheit the whole time. This is the inside, while the outdoor temperatures were as low as minus 15 degrees Fahrenheit. A second type of system for passive solar heating is indirect gain. Now here we're going to collect and store the solar energy and distribute it from one part of the house to the rest of the house. Typically this is done with something called a trome wall, and it's a massive black masonry wall or water wall placed just a couple of inches, 10 centimeters behind basically a window, a south-facing glass area. So then the sun passes through the glass.